Morning. Today we are going to see about the transformers. The basic principle involved in the transformer working principle is one is electromagnetic induction, which we have studied earlier, and then is the mutual induction. What is a mutual induction? The process by which a coil of wire magnetically induces a voltage in the nearby coil which is in a close proximity, right? This is what mutual induction. So three parts you have to remember mainly. One is the primary winding. This part is the primary winding. This is the secondary winding here, right? These two are held together by the core, which is made up of a silicon soft seal. Okay, it is also used to magnetize the materials in between. How is the working principle? Alternating current. This is one more thing. Here the primary coil is been connected to an input electrical source. Here the output part is connected to the load we receive, right? So when a current is being induced in the primary coil, alternating current means every now and then the magnitude and the direction will be changing, right? So when the voltage is applied in the primary coil, the alternating current changes the direction, creating a magnetic field around the primary coil, right? What will happen? This magnetic field is channeled through the shared iron core, which then concentrates the field and guides to the secondary coil, right? What will happen in the secondary coil? The changing magnetic field from the core passes through the secondary coil, cuts the winding. Therefore, according to the Faraday's law of induction, what will happen? An induced voltage will be there in the secondary coil, right? So how to determine the voltage? The voltage determination is based on the number of windings in the primary, number of turns in the primary to the number of turns in the secondary. Okay, this is given by the formula. Turns ratio is equal to Vp, current in the primary, voltage in the primary by voltage in secondary, equal to is, if you want, the number of turns in the primary to number of turns in the secondary, right? One more thing you have to remember: if the number of turns in the primary is higher, right, then the secondary, then it is a step down transformer. If the number of turns in the secondary is higher compared to the primary, then it is a step up transformer. Sometimes both the turns will be equal, so it is known as an ideal transformer, right? So this is the formula applied for finding the voltage as well as the number of turns in the coil, right? So it is used in the application for transformer is, it is used in the long distance power transmission. There the output voltage will be higher, so we are stepping up, right? We are using a stepping up transformer, means there is a low current, right? Why is there is a low current? Because the loss will be minimum.